Good afternoon, everyone. Welcome to yet another webinar by Data Platform Geeks. My slides say SQL Maestros. That's fine because the content is from our SQL Maestros masterclasses and accelerators. But today, as you all know, I am delivering this webinar for Data Platform Geeks. Today's session is about simplifying SQL Server performance tuning. My name is Amit Bansal. I am available on Twitter, which is A_Bansal, and my email ID is amit.bansal@sqlmaestros.com in case you wish to write to me. I work for a company called eDominer. I guess many of you might know about that already. And as you all know, I spend most of my time with SQL Maestros and Data Platform Geeks. Under SQL Maestros, I do training, consulting, and content development. Couple of services out there for you to browse. And under Data Platform Geeks and SQL Server Geeks, I help the entire team with a lot of community initiatives and activities. And one of them, of course, is Data Platform Summit, our annual conference. I again assume that many of you would know about this conference. In case you don't know, please visit dps10.com and you will have all the details. 3 days of conference and 2 days of pre-con, very heavily attended by people from across Asia. Yeah, that's the website you could visit. I have been working with SQL for many years now. I started in 1997 as a developer, and then I moved into database administration. And of course, performance tuning is one of my core area of specialization. Since 2005, I have delivered more than 500 different types of assignments, training, consulting, mentoring projects, POCs for more than 200 customers globally. I am a Microsoft Certified Master and an MVP awardee also on SQL Server. I speak at global conferences whenever I get an opportunity. And of course, the annual conference, Data Platform Geeks, SQL Server Geeks have been some of my community initiatives. That's the URL which you can visit, sqlmaestros.com/amit-bansal in case you wish to know more about me. So what are the takeaways for today? Today's session is about simplifying SQL Server performance tuning. Now, performance tuning, to be honest with you, is not a simple subject. It is complicated to a certain extent, but there are different parts of it as to how really you perceive a performance tuning case. How do you really approach your troubleshooting with SQL Server? So it really depends on tactics, your techniques, and your approach. My intention today is to show you how you could simplify and take a very simple methodological approach towards solving majority of SQL Server performance tuning cases. Of course, there are many cases where a simple approach might not work and you need to have a lot of advanced knowledge and deep expertise to solve those problems. But many of those problems are uncommon and they do not happen on day-to-day basis. Today, my idea would be to show you many common problems that you face on a daily basis and how you could approach them. So today's takeaways are what's happening with my query. So when you submit a query to SQL Server, whether you run a stored proc or you submit an ad hoc query or you fire a report from client, there is a query that is running behind inside the database engine, and you're not getting the expected output, and you're doing a lot of different guesswork as to what's going on with your query. The second takeaway will be what's really happening. So how do you find out what's really happening? On one side, you're doing a lot of guesswork, that it could be because of blocking, it could be because of indexes, statistics, and many different other things. But what really is the root cause of poor performance? That is how to investigate that. I'm going to talk about that. Now, next is what's really happening. How do you know that? How do you find out what's really happening? So there has to be some tools at your disposal. And I'm going to talk about DMVs and extended events. Next, what can I do after I know what's happening? Well, answer is very simple. You go ahead and fix it. So I'm going to take you through a step-by-step approach towards simplifying SQL Server performance tuning. And this session and the content is just level 200. I'm not going very advanced into a subject. So if you are already an advanced user or an advanced DBA, you might find this content at basic level. It can serve as a good refresher to you. So most welcome. So first, what's happening with my query? Now, day in, day out, whether you're working as a DBA or a developer or as a team lead, or you're on the business side of things as a data analyst, this is a situation that you will come across quite often, which is you have submitted your workload, you have submitted your batch request, you have submitted your stored procs, you're finding an update statement, and your query is not responding. So what's happening? Where is the query stuck up? There's a lot of guesswork that happens. For example, you are waiting. Um, the report does not run. You're not getting the output. You start guessing that maybe SQL Server is hung or the server is hung, or in some worst cases, even the query times out. Finally, the result is a lot of people tag SQL Server as, oh, SQL Server sucks, which means this is not the database and this is bad, etc. So a lot of conclusive stuff starts coming out. Now, you need to investigate what's really happening with your query. How do you investigate what's really happening with your query? Before we try to investigate and try to find out the root cause of a performance issue, consider this. In a most simplistic manner, there are two things that could be happening with your query. Either your query is running, that's one thing, or your query is waiting. Now, a third state could be there, but I am not discussing that today in the webinar, so I'll not even talk about it. But let's take the simplistic approach, because the session is about simplifying, is whether your query is running or it is waiting. Now, when I say that I'm taking a simplified approach, it might not be really as simple as that, okay, it's running, so it's running, we'll just keep waiting. Or if the query is waiting, then we just go and find out what it's waiting for and we try to fix it. Sometimes things are not as simple as that, but let's take the simplistic approach. So if your query is running, which means it's running and it is doing its job that you have asked it to do. Let's take a very simple example. You have a table with 1 billion records and you simply say select star from that table. You don't expect the output to come out in less than a second. It's definitely going to take more than a second. It might take 10 seconds to 20 seconds or even more than a minute, depending on your hardware configuration or how fast the disks are or how fast the network is, etc., etc. It's dependent on a lot of different factors. Now, in such a scenario, friends, let me first tell you, there are waits also that are happening. It's not that you have submitted your query and your thread is constantly running. It does go under a few cycles where it is just waiting and not really doing anything. But from a layman's standpoint, it is running, which means it's trying to scan all those 1 billion records. It's scanning all those data pages where you're getting the data out, and it is being served from the SAN or from the disk all the way to the client. So it's going to take that much time. And likewise, if the same table had very few rows, it could be a small table with just a few thousand rows, and you say select star, the data would really come in less than a second. Now that's about the query which is running, but your query also waits. Now, for example, you say select star from this table, which is big, which is huge, 1 billion records. It's unlikely that your query has a very smooth ride. There are no other users on the system. There's no contention on the server. There's no contention on the network. There is no contention at the IO, and your query sails through. That is a very uncommon scenario, really does not happen in production box, which means your query has to pass through many hurdles. It has to face contentions at IO, network. It has to face contention at CPU. It might have to wait for memory allocation, etc., etc. Let's take a small example again. You say select star from this big table with 1 billion rows, and you say order by a particular column on which there is no index, which means SQL Server will have to do an in-memory sort. And for such a operation, it might need a lot of memory, and there might not be enough memory on the box. So what will happen? Your query will have to wait. It will have to wait for memory grant. Likewise, it might have to wait for CPU cycles if there is heavy CPU bottleneck. It might have to wait for IO cycles or IO ports if there is already a lot of users connected to SQL Server and they're doing a lot of IO activity. That is a scenario where we say your query is waiting. So in the life cycle of your query is running at times, and at times it is waiting. So it keeps going that way, running, waiting, running, waiting, running, waiting, and it just continues to do that. Now, how do you know what's happening? So the idea is I'm talking about waiting and I'm talking about running. Now, running is fine, but when it is waiting, you want to find out what it is waiting for. So how do you know, and how could you investigate or troubleshoot? Well, there are three tools, popular ones that you can use: dynamic management views, extended events, and you can also use SQL Trace and Profiler. So SQL Trace and SQL Profiler are are very, very common from the early days of SQL Server. I'm sure all of you must have been using it. Dynamic management views are really the bread and butter for any DBA or even a developer for that matter who is involved in performance troubleshooting. But the tool that really stands out is extended events. Extended events is a very, very powerful tool which will help you dive deep inside the database engine, extract a lot of information that is otherwise not available using even DMVs or other simple means. Extended events, consider extended events as successor to SQL Profiler or Trace. And as you might know, that Microsoft has stopped investing in SQL Trace and Profiler because extended events does all that work and does it even better and does a lot more than what Profiler was capable of. Let me also talk about dynamic management views and functions. We collectively call it as DMVs, but DMVs and DMFs are two separate things. But yeah, we'll just refer to them as DMVs. And there are more than like 200 such DMVs, which will allow you to extract a lot of performance data, performance information about SQL Server. I can bet you or assure you, I have not seen any DBA, or I shouldn't be even coming across any database administrator who would not have used a dynamic management view. DMVs were introduced in SQL 2005. Extended events were introduced in SQL 2008, and the GUI for extended events was introduced in SQL 2012. Profiler has been there for many years. So these are the tools that we are going to use. Now, what can you do after you know what is happening? Well, when these tools give you a lot of information about the current status of the query, whether it is running or waiting, and if it is waiting, what it is waiting for, well, you just have to go and take corrective action. Remember, these tools will only help you investigate or come closer to the root cause of the performance issue. It is you that has to find out, who has to find out where exactly the bottleneck is and fix that bottleneck. You got to diagnose it. None of these tools for that matter will automatically do anything. It's like these tools are aid to you. It's like these are just like a doctor has his tools and he tries to investigate or troubleshoot a disease. This is exactly what you are also going to do, and they will help you come closer to finding out the root cause of the performance issue. But diagnosing it and fixing it is definitely your job. With this basic overview, let me dive into some demos. I'll start with simple demos to just get you started, and then we'll go into a little more into intermediate and advanced demos. So time for me to switch over to the VM now. All right, friends, a quick check from all of you. Screen, are you all able to see my screen? There is a notepad file that is open, and I have SQL Server Management Studio in the background. Hope all of you are able to see the screen, and I'm sure all of you can hear the audio as well. But just put yes for screen for the time being, because I can see someone is saying that he's not able to see the screen. Okay, great. Okay, so all of you can see it. Fine, friends. Let's move on, and let me start with. So friends, what I will do is, the first thing, I'm not really opening any script, and this is really just for the beginners, just for the starters. Let me show you a quick thing. Okay, so I mean that this is really the basis of what I mean by simplifying performance tuning. So let me use AdventureWorks 2012, and I say go, and then here I will say, let's say begin tran, and I'm going to update a table call, let's say person.person, and I will say set first name equals to your favorite Amit, and I'll say where business entity ID is equal to 1, and I will execute this. Now, all of you know that this is an in-flight transaction. I have fired an update on a single row. which is this row ID 1, and I have begun a transaction, but neither have I committed nor have I rolled back. Which means in another window, let's do a new query. If I say select star from that particular table, which is person dot person, and if I execute, you will see that this particular query is now waiting. Now this query is waiting. Now I know it is waiting because it's being blocked, but that's really what I was trying to tell you. Either your query is running or it is waiting. Now some of you might say, well, it's still running. I agree, it is still running, but it's waiting for a resource. What is that resource? The resource is basically the page on which that record is located, and probably that row is logged, so it's not able to access that row. Now how do you investigate something which is as simple as this? Now remember, I told you this is just for the starters. So what I will do, this is my query that is waiting, which is query number session 55. As you can see here, this is session 55. Can I zoom in and show it to you? Yeah, I can. So you can see this is session 55, and I will simply say select star from sys.dm underscore os underscore waiting tasks. Now this is the DMV that I'm using. Now this DMV belongs to OS, SQL OS category. It comes under SQL OS category like that. Like this, you have execution environment, EXEC, you have database, DB. So there are different categorizations. And what am I trying to do? I'm trying to find out all the waiting tasks. Now behind this particular execution, there is a task, there is a thread that is waiting. And if I filter on, if I say where session ID is equal to 55 and I execute, you will see that the query is now waiting. What is it waiting for? It's waiting, the wait type that is assigned to this particular query is LCKMS. Now, if you decode this, it stands for lock mode shared, which means this particular query is actually waiting to acquire a shared lock on a particular resource. Where is the resource? If I scroll at the end, here is that resource description, which means on my page ID 1472, I'm trying to acquire a row lock on this particular database ID, which is 7, and file ID 1, which is my data file. And that's the resource I am actually waiting for. So from a layman's perspective, yes, the query is running, but it is internally inside the database engine, it is actually waiting. Now, the most interesting aspect of this output of this DMV is that it tells you it is waiting, and it also tells you which is the blocking session ID. Now, blocking session ID is 52. This is the same session where we ran the update statement, and this is the statement which is neither committed nor rolled back. But now, let's try to find out what is this session doing, 52. Okay, so if I now, let me hold on to this one and I'll create another query. And if I say select star from sys dot dm underscore exec underscore sessions, where session ID is equal to 55. Now, if I execute this, I see that session ID 55 is there, and the status of this session is running, which means the session is alive. But the interesting aspect is, from my sessions, I can see that the session is there. But if I change my session, or let me copy it, because then you can see both the scripts. Instead of sessions, if I say requests, and if I look at for session ID 55, okay, I'm sorry, I should be looking at 52. That's the mistake I made. So I will look at 52. So when I look at session ID 52, here is my session 52. And if I scroll down on status, I can see the session is actually sleeping, right? Simply because session 52 is actually not doing anything now. It actually ran this statement, which has completed successfully, and this particular session is just now idle. It's not really doing anything, and consider this idle state as a sleeping state. So the session is sleeping. What happens to the request? Is there any active request? If I search on 52, I see that there is absolutely no active request. Now the question is, if you want to extract the T-SQL statement as to what really was the code that ran, which is blocking session ID 55, which means I want to extract this code. Now, right now you see everything in front of you because I'm doing it, but in real world, you would not really know what was the code, whether it is an update statement, whether it is a batch process, what is it? Now, because there is no active request, it's very difficult to extract this information, right? For example, there is a query here, which let's say select star from, for example, select star from, what is it? sys.dm underscore exec underscore SQL text. And what does this do? If I do this for session ID 55, see, and as I said, it's very, very basic for beginners. If I run this for 55, I have a SQL handle. I am getting this for SQL handle because my session 55 is actually waiting. So it's kind of still really active. The request is still active because it's waiting. So if I get the SQL handle, and if I can supply the SQL handle here, I can actually extract the text for the input buffer for my session 55. And here is that the code is select star from person.person. This is what I was trying to do. This is what I'm trying to run. But for 52, as you know, I just don't really get the SQL handle because there is no active request. Well, here are then these challenges. Then my sysdm exec SQL text actually will not work in this particular case. So what I can do, I can actually revert back to an old statement command dbcc input buffer. Many of you might know this from SQL 2000 days. So input buffer, and I just put 52. If I say SQL dbcc input buffer 52 and in brackets, there I go, always make that mistake. And if I say dbcc input 52, I can get that statement. So this is the statement that I'm trying to run in my session 52. Well, there is another way to figure this out, to find out what your statement was. So we have another DMV, select star from sys.dm underscore exec underscore connections, and I can say where session ID is equal to 52. And now I'm getting connection information. This particular object also has one of the columns here, most recent SQL handle. So the last SQL statement that has run, you could extract it from this connection object, because after that it went into that idle mode. And if I replace it here and I execute my SQL text DMV, I can get that output. So see, what I'm trying to do is troubleshoot a query which is not returning an output to me, and I'm using a bunch of these DMVs to find out what exactly is going on. And as you know, this is just very, very basic to just get you started. And this is still waiting, and you know this is going to wait infinitely because there's no lock timeout. So for a moment, if I roll back now, and I will release the lock, exclusive lock, which I am holding here, then this query is going to go through and it runs and I get the output. Okay, so a quick question, and you can please respond in the chat window. This very basic example, was it clear to all of you? If it is clear, please put yes in the chat window. And if it's not clear, you can put no. That's fine. Okay, perfect. Most of you have got very simple. Thank you so much. Let's move on. Now I'm going to take you through a slightly different kind of example. So I'll close these windows and let me just keep this one because this might come handy later on. Now, friends, so the idea is that now I'm sure many of you have at least got a sense that when a query is running, it is running, all good. But when it is waiting, like in this particular case, it was waiting for a lock resource and a wait type LCK-MS was assigned to it, then it could have been waiting for, then there is a possibility that it could wait for many other things. Yes, if I say select star from sys.dm underscore os underscore wait stats, which will give me the statistics of all different wait types, you can see that there are more than 700 different wait types here. Your query could actually be waiting for anything under these wait types. Honestly, I don't know really all the wait types, and I haven't found anyone who knows all of them. Many of them are not documented also by Microsoft, but yes, Most popular weight types are documented, experts have spoken about it, and we know how to troubleshoot them, etc., etc. So these are a lot of different weight types. Now the idea here is to not to really just go through the common weight types. That's not the purpose of this session. This is one of the YouTube channels you could actually subscribe to. Sorry, I'm digressing a little, but I might not remember this again. So if you want to watch a few videos that I've recorded on and I've put them on YouTube on weight type, so you could actually use this youtube.com SQL Maestros. There I would have a couple of videos. I would also request Satya to put down this link. Oh, I can also put it down for you there in the chat window. Okay, there you go. Thank you. Okay, so now, as I said, friends, this session is not about just trying to talk to you about all the different weight types, but this session is about simplifying, right? So now let me pull up another example. Now, I'll go to my scripts and let me just pull out the. Okay, so friends, now if I will show you a query here, let's say, look at this query now. Now I'm trying to just show you how you can simplify things. Look at this query. Use AdventureWorks, and I'm running something in a loop, which is fine. Look at this query, select count star, and I'm doing some join. I'm actually joining about 5 different tables, and I'm using full outer join. There is no filter here as such, no predicates, which means just join all the rows from table 1 to table 2, and then the output of that to table 3, and then the output of that to table 4, etc., etc. So now when I run this query, and let me close this, and when I run this query, you will see a lot of different weight types related to page IO latch. Now, why am I trying to show this to you? The query is fine. It is going to run, but because I'm trying to read data from so many different tables, occasionally it will wait for IO cycles. So when I run now, and I can see in the database engine, no workload is waiting on page IO latch. What is page IO latch? Page IO latch is a weight type, which means that if any query hits this particular weight type, it's actually waiting for an IO operation to complete. And this IO operation is nothing but reading data from disk, which is reading the page, the 8K page from disk into memory. Nothing is waiting. So now when I go and try to fire this, let me execute this. And now when I run this, you can see that many threads, I just simulated a couple of threads. You can see in the command window at the bottom, many threads are waiting on page IO latch sh here. Okay, which means these are the queries that were waiting. Some of them occasionally hit. So sometimes 2 workloads, sometimes 4, sometimes 6, sometimes no one at all. But okay, obviously I do not have enough IO ports to cater to so many threads trying to hit the same data and read from the disk. Remember, in that query, I'm doing dbcc drop clean buffers, which means I'm clearing the cache every time. Okay, friends, so I'll just close this window. Now, what happens? What am I trying to show you? What I'm trying to show you here is that many of these queries that are running, when they hit page IO latch, of course, they go into that wait mode. But the moment their IO operation, that resource is available, it will go back to the running status and it will complete. But sometimes this can go really worse. If there is a huge IO bottleneck, this can go really worse. Now, I will show you another example where you will try to do something similar, but it's actually not going to hit any IO page IO latch wait type. So let me take a query here from, let's say, memory pressure. So I have a database here called use tuning, and I just created a sample database for the purpose of demonstration. And now if I run, if I do a dbcc drop clean buffers to just delete everything, and if I execute this one, and then I go back here, and let me first show you if I'm really waiting for anything. Now when I run this, no, I'm not waiting for anything at all. And we run this particular query. Now before I run this particular query, one thing we want to do is, let's say, set statistics on, and let's say set statistics time on. Okay, and many of you know what this means. IO on will give me the IO statistics for a given execution, and time on will give me the time stats. When I turn this on, let's start with our test. I'm going to run this. Tuning itself, this database has a few large tables, and when I execute this and I try to check out this, you see this is still running, the query is still running, but there's nothing waiting on page IO latch. The query is very, very similar, and I will explain you in a while. Now, what's going on? No query is waiting on page IO latch, even though this query is still running. It's still executing the data, but nothing, but it's not waiting on page IO latch. Now, the query is done. Now, two things that I want to tell you. First, it's not really joining many tables, unlike my previous query. Point number one. Point number two, I'm only doing a singleton execution of this query. I haven't created 10 different threads. If I had created 10 different threads, then of course those threads, by 10 different threads, I mean I'm simulating users, then they definitely at some point would have waited to get their access to IO ports to complete their IO operation. Now, you saw that this wasn't hitting on page IO latch, but what does this mean? This is running and it's not really waiting for anything. So running and waiting, are they the only reasons, or are they the only hints as to how, if there is a performance issue? Absolutely not. If you look at the execution time, this query took 20 seconds approximately. So let's go and zoom a bit into this. It spent about 40 seconds or so on the 4 seconds on the CPU and CPU cycles, and it has spent about 20 seconds to finally execute the query, which means the time this query has spent on CPU is really less, because we're not doing much of CPU computation. We're only retrieving data from IO, and that has taken 20 seconds to execute. And one of the things you will notice here is, look at this portion, which means this is the place where it's spending maximum time. Logical reads, it has read 24,000, approximately 24,000 pages. So now the point is, this query was running, it wasn't waiting for anything. So my question to you is there not a scope of improvement here? Well, there could be. This is where we move beyond just waiting or running, but we're trying to look at other aspects. So when I run this query again and I look into, let's say, display estimated execution plan, and this is the plan that I get, and you can see there is a table scan happening at table orders here, and Management Studio is recommending me a hint here, which means there was massive scan going on this object table orders. And if you look at the execution plan a little more closely, this is the place where the query has spent more than 50% of its cost. If we can fix this, maybe performance of the query can improve, because it took 20 seconds. Now, Management Studio tells you that a potential index could really be helpful. Now, never go and create these indexes blindly. Don't follow the recommendations blindly. Use them as a hint. Management Studio does a fantastic job there to give you a hint. So you go look at the hint, review it. If it makes sense, go ahead and create it. If it doesn't, you got to go in and continue your investigation further. Now it tells me to go ahead and create this index. So for the sake of this demo example, I'll just go and create an index. So I'll go to query, just specify template parameters, and I just say IDX. For which object is this? For EMP ID, IDX, and I say EMP ID. It actually tells me to create an index on employee ID, because that's one of my joining columns, and include many of these columns which are there in my select list. Unfortunately, Management Studio in most cases, or maybe even almost as far as I've seen, will always advise you to create covering indexes. You got to be careful, because the moment you create this non-clustered index, you're actually creating a copy of the data with all these columns. And if, let's say, these are 5 columns, if you just have 10 columns, let's say all 10 columns are equal in their size, and it's 1 billion rows, and the table size is 10 GB, you take the 50% of the column with all the data, you are actually trying to create another 5 GB of data on the disk. But yeah, a lot of caveats to this, friends, and it's not a small discussion, but for the time being, just let's go ahead and create this index. So when I go and execute this index, just takes a bit of time. While the index is being created, a quick recap. What I was trying to show you is that I ran a query. It wasn't waiting on anything, but I am trying to show you that even beyond that it's not waiting for anything, there are scope of improvements. Index gets created. I can do the DBCC drop clean buffers. I can turn these fellows on again, and I will run this particular query again, and let's see how much time it takes. This time you're reading data from the index, and while it's running, do you get any wait type? You don't get any wait type. The query is, however, still running. Even though you've created the index on this particular query, how much time does it take? This time you're scanning the index. It has just taken a few seconds, less than 3 seconds. So if you go to the messages tab, again, because you're getting all the data, table order scan. Now look at this. A perfect example of how just blindly following the index recommendation of Management Studio might not be helpful. TBL orders still scans 25,000 pages simply because you're doing select star. You're just trying to get all the data, and it has just taken slightly less than like the performance improvement has just been over a second, which is not really a big deal given the cost of this big index. So what is really going on? If you go and look into the estimated execution plan here, instead of a table scan, you're just doing a non-clustered index order scan. Well, that's pretty much it. So this was really not where you could get any performance improvement. So friends, the lesson from this here is now the management studio does not really give you any index recommendation. You blindly created an index which actually promised you or suggested you 75% performance improvement, but you are just not getting any improvement here. Simply because earlier you were doing a table scan, now you're just doing an index scan. The query is like that. The query is like that where you're just trying to retrieve all the record. All you have done is just taken some data out of the clustered index and the leaf pages and just created another object of it. And SQL Server, instead of going and scanning the table, is just scanning the non-clustered index again. So there's very little you can do here with this particular query. Okay. Let me close this example. A quick check with all of you. Was this example clear? The message from this example, so please use the chat window and say yes, no. The example from this window is that no waits. Management Studio says go ahead and create index, which will improve performance. You go ahead and create the index, but it does not give you any performance index because you got to look at the query. The query itself is just scanning all the data without any predicate or filter. So the new index that you create gives you minimal performance improvement, or actually nothing at all. Now I will show you a slightly more advanced example. Okay. So let me just close all of this. So I go back to the window here. And now there is a query here, which looks like this. What are we doing here? DBCC drop clean buffers, that's fine. We are trying to retrieve data from SPT values here, one of the objects in master database. And we're doing a cross join, and then we are doing a multi-level sort. And we're trying to retrieve top 1000 rows. Now, we are going to first do the same thing again, which is I will say where two things I will do. Session ID is equal to, well, that one is 52. So I'll say 52. So first let's check where session ID is equal to 52. And is your query waiting for anything? Well, nothing is waiting on session ID 52 because nothing is running in 52. Now, when you run this particular code and will execute this, and then I go and check on 52, you are waiting on 52. But what are you waiting on? You're waiting on a wait type called CX packet. Okay. Now, this particular wait type CX packet, so many threads are there, and let me go ahead and stop this. First, let me explain you the basics of what's going on. In most simple terms, when you ran this query was parallelized. So if I take this particular query and look into estimated execution plan, there is parallelism in this particular query, which means my query gets broken down into multiple threads. So you can clearly see parallelism happening, these yellow icons say. So my query gets broken down into multiple threads, okay? That's a simple understanding here. So you can see multiple threads. Session ID is same, 52, but session threads are 1, 2, 3, 4, 5, 6, 7, 8, and of course the controller thread, which is 0. So that's a given. It's a parallel execution. Point number one. Point number two, what do you mean by this CX packet wait type? Well, in simple terms, when a query is parallelized and you get multiple threads, some threads finish their job earlier than the other, and they wait on CX packet, which is simply meaning that parallelism is happening and threads are waiting on each other to complete their job. CX packet here doesn't mean that things are good or bad. It's just a wait type associated with parallelism. It could be bad, it could be good. That's a long discussion, and that's a different discussion altogether. But now look at the fun. Query was running. The point was query was running and it was giving you the output. Now I will do something different. Now I will go and do multiple executions of the same query. I'll go to add client. Let me just double click this and okay. And let's go and comment this now and wait type resource semaphore. Now what do you see? So lot of threads are waiting on resource semaphore. But just to be fair, let me first close this. And first, I want to show you that when I am not running the query, is anything waiting on resource semaphore? Nothing at all. Now you see, I've commented this. Let's forget this for a moment. Session 52 is gone. No workload in my database engine is waiting on resource semaphore. Now I will simulate 10 clients of the same query and then execute this. What do you see? Many of those threads are now waiting on resource semaphore. And when I take another query here, another DMV, oops, it's so difficult to, when you stress SQL Server so much and the VM, it just gets very slow. And I execute this now. On DM exec query memory grants, you might see many of them. So now all good. Now let me just go ahead and stop these workloads and let me explain you what's going on. Now this is a slightly advanced example. And now at least I will not say that I'm trying to simplify SQL Server performance tuning. Other examples were simple. This one is a little complicated. What is happening? This particular query that I just showed you earlier, this one, I ran 10 different threads for this query. What happened is this query is actually expensive. Why it is expensive? If you look at sort here, this sort is an expensive fellow. 97% of the query cost is with this sort. And when you actually run this query, this sort needs lot of memory. How much memory it needs? I can find this out from the memory grant DMV. And if I show you the output of memory grant, each execution of the query asked me for 873,664 kilobytes, which is close to 800 MB. So each execution of the query asked for 800 MB, which means if all the 10 executions have to execute, SQL Server has to allocate close to 8 GB for 10 executions of the query only for that sort operation. Now what happens is, excluding or really not getting into the depth of SQL Server architecture, let me tell you, SQL Server will not blindly grant that huge memory for every execution. What it does is, there are concepts of gateways and semaphores inside SQL Server, which means all queries that are asking for this much of memory will not be granted. SQL Server will first prefer less expensive queries to go through those gateways. So what you see is query number 1, third, fourth, then 6, 7, 8, they get their query. So you can see granted, and you can see the grant amount there. So these queries get their memory grant, but the ones that are saying null, they are waiting. What are they waiting on? They are waiting on a wait type called resource semaphore. Now, why are they waiting? Simply because SQL Server has an algorithm which says, which will not allow every query or every workload just to ask or get any amount of memory it wants. There are certain checks and balances in place, and I'm not getting into the depth of that, but there are some checks and balances in place where these queries will have to wait. When these queries that have got their memory grant, when they are done with their execution, when they complete their execution, these queries that are waiting for resource semaphore or in that queue, they will get that memory which will get released by the ones that have completed their execution. If you scroll down later, you can actually see what is the order in which they are waiting. So you can see their wait order. Look at this column, wait order 0, 1, 2, 3, which means any of these queries, when they are done, the query that is first in the order will get their turn and will get the grant and will execute. So the idea is very simple. For query execution, the amount of memory reservation that the SQL query engine, the processor, does is limited, and there is a check and balance there in place, and the queries that are least expensive will go through first, and remaining will wait in the queue. This is why sometimes what happens is expensive queries like these. Now, will I get the cost because this was estimated? Look at the estimated subtree cost. The cost of this query is 288 units. They're not very expensive, but the point is it asks for a lot of memory. Queries, expensive queries and queries with high memory grant, if all of them execute at the same time, they're not really going to get the grant that they want, and some of them will have to wait. This is precisely the reason when such queries come in abundance, a lot of users are trying to fire those queries. Some get through and quickly execute and get the output. The others are waiting in the queue for the previous ones to complete. And this is why you get unpredictable performance. Sometimes the queries are running, they get the output quickly, your users and business is happy, but sometimes those queries are waiting. So what you got to do is, friends, you got to keep a tap on this thing called resource semaphore, but not really resource semaphore, that's a wait type, but keep a tap on this waiting task. Try to figure out what is your query waiting on. If your query is waiting on IO, page IO latch, that's to do with IO. If it is waiting on resource semaphore, it could be to do with memory grant. Like that, there are many different wait types that you can actually keep an eye on. And of course, this is a real-time DMV, which means the data here is not persisted. And that's the reason why we suggest baselining as a concept to implement, so that you can periodically capture this data from waiting tasks and put it into your baseline database along with a timestamp, so you can go back and review as to what did your query wait for. Another way to do this is actually use extended events. With the help of extended events, you can actually capture, suppose you have a stored procedure or a query, and you really want to keep track of every wait type the query encounters. So, why not take a small example of this particular query? I can actually show this to you using extended events. So let's say you're troubleshooting a stored procedure or a query, and you want to capture all the different wait types it goes through, and then later review it. So you can go to management. Let's go to extended events, right click, and let's use session 52 here, expand session. Let's use a new session wizard. This is very, very small, but I'll just take you through it, no problem. So my session name is, let's say, track wait stats, and then I move next, and I use, I'm not going to use a template, and then I will say, what am I going to track? Let me filter on wait, and then I can say wait info, get all the columns for wait info, all the payload, and some global fields. And in the global field, I can actually take session ID. Now, where is my session ID here? There is my session ID, and then I can take SQL text, and then I can move next, and then I can filter. So I can actually filter on session ID. I know maybe in your screen this could be a bit small. There you go, session ID. And let's say our session ID is 52, and I put say 52. And then I can do this next, and we can save this data in ring buffer for the time being, which is in memory. Next, and finish. So extended events is a very powerful. If you look at the interface and the steps that I've just done, they're very, very similar to finish it, and very similar to the profiler and the trace, and then start the trace. So I did a filter on 52. So if I refresh this and expand track wait stats on my left, and I will right click and watch live data. Now, if you see that really no wait type is being captured, simply because nothing is running in 52. You remember I put a filter on 52, but just for the time being, just for a very quick demonstration, if I execute this, and this is going to run through many different wait types, and then it's running, then I can stop this, right? Multiple executions I did. Now all the data gets captured here. You can see wait info, and what kind of wait. This time my wait here was scheduler yield, because simply because this time you didn't run multiple users. So it is all SO scheduler yield. SO scheduler yield wait type means that the thread actually went back to the CPU for its execution. It did not really wait for its for any resource, but its quantum of 4 milliseconds was over. So let me go and clear this, and I'll take a different example. So let me clear this one. And instead of running this, let's take our own query tuning example. So how about this one? And I'll copy this data and to 52, and I'll paste it here. And let's say use tuning. And then let's run this. Let's say this was a stored procedure. So first you ran this query, then you ran this one, then you ran and while you're running all this, there you go. And if we stop this, and now you can see a lot of different wait types have come. So what I can do is I can actually stop this, and now I can do some mathematics on this. I can go to my column choose, and I can do some grouping. I can actually group on. So first let me show wait type here, and I'll just zoom in, show the column here, wait type, and the duration also I can show in the column table. And then I can do a grouping on wait type, and I click on OK, and now it's going to group. May take a while. There you go. And I can do an aggregation on duration. So when we say duration, I can do a sum on this, and I click on OK. Now, let me quickly zoom in a bit for you to see this. So when my queries were running, you can see that through the lifetime of my query, network IO was the most hit wait type, then a couple of others out there. So I can investigate the life cycle of my complete query. So what I can actually do is, when I'm investigating important stored procedures and important stored procedures and wait my queries, ad hoc workloads, etc. And they're important mission critical workloads, I can actually create extended event sessions and track their wait types and identify, apart from running, what exactly was my query waiting on. And this way I can try to investigate further. Remember, these wait types are giving me hints where the potential bottlenecks could be, and then I can go and investigate further. So these are all the different techniques. Mostly the extended events and DMVs are very, very helpful. So I'll just close this, and that's all with the demos, and I'll go back to the presentation. Hope the demos were useful today. You can connect with me, friends, here on A_Bansal. That's my user ID. And you can also connect with SQL Maestros. A lot of this content comes from our masterclasses and accelerators. And a quick word, you can go to sqlmaestros.com. I am planning to come up with accelerators, one-day performance tuning classes across India in various cities. There is a small poll also going on, and after this webinar, you will get a link to that poll. So you can just participate in that survey and let us know which topic interests you the most. And then we will do classes based on your suggestions. Many of the demos that I just did now, if you want to practice them, those ones and many more, CPU indexes, query tuning, and anything related to Microsoft Data Platform, Azure, SQL, etc. Hands-on Labs is a wonderful project that you could use. It's a community learning solution platform that we created, and we have more than 120 labs today in this on this portal. So just go to sqlmaestros.com or just go to hols.sqlmaestros.com and create your free account and get access to some of these labs. And yes, I think all of you know about the conference. So I quarterly invite all of you to join Asia's largest data platform conference, focused on 7 tracks: database administration, development, performance tuning, data science, artificial intelligence, big data, cloud, and whatnot. Microsoft product experts from Redmond are going to fly down and deliver sessions here. Likewise, we will have MVPs and MCMs from 15 countries. We're very grateful to our speakers who spend so much time for the India SQL community. We will have 7 parallel tracks, more than 100 sessions by 60 speakers across 3 days of conference. There are 2 days of pre-cons also, where we have 12 pre-cons. We have 6 pre-cons on August 7 and 6 pre-cons on August 8. That's a small typo out there. dps10.com will have all the details for you. So friends, with this, I am all of you are members of dataplatformgeeks.com already. So continue to be a member there. There are a lot of good stuff out there, learning resources that you can leverage, including labs, free SQL videos, etc. Please join these Facebook group and also the SQL Maestros YouTube channel. Please also join the SQL Server Geeks YouTube channel. It's just youtube.com/SQL Server Geeks, where you might get access to all the recordings. Well, thank you very much for your time. And I will now take questions. Please use the Q&A panel to put down your questions. And those who are leaving, thank you very much for your time today. Hope this 1 hour was useful to you.